Let's now, just for fun, consider an example of attack that Bob might try and perform on weak string erasure. We've already seen that we can prove security against Bob if he has a limited quantum memory. But you might be asking, if Bob has no quantum memory at all, what is actually the best possible attack that he could perform? If we think of what Bob wants to achieve, namely his goal is to guess the string x, given k and theta, because remember now he's only classical, the question is, what is the best thing he could do? The question here, where we allowed him to prepare the states row A, is basically given by the uncertainty game. In the sense that here, if we allow him to prepare states, then the best thing he can do, the best kind of guessing probability, is precisely equal to the maximum probability that he can win the uncertainty game, where we maximize over all states row AK that he could prepare. So we noticed that if L is measured in the standard and Hadamard basis, then Bob can prepare this state, this state, this state, or that state to achieve the maximum probability of winning the uncertainty game. So this gave him a winning probability of these roughly 0.85. So these here are in fact the states of minimum uncertainty. This would be Bob's optimal attack to prepare one of these states of minimal uncertainty in the uncertainty game. But of course, we have said that we gave Bob a little bit more power. He's not actually able to prepare these states. In the actual protocol, Allison prepares EPR pairs and sends 1/2 to Bob. So can Bob still achieve the same guessing probability as in the uncertainty game? The answer to this is yes. And the key to see this is as follows. Note that Alice and Bob shared this EPR pair. The EPR pair looks maximally entangled in any basis. In particular, also if I pick this direction on the block sphere, and I will call this here, say 0 Bob and 1 Bob, then the maximally entangled state is also maximally entangled in this basis. So I could write this as 1 Alice, meaning this direction. Let me call it 0 Bob, 0 Bob, 1 Bob, 1 Bob. This means that if Bob measures his qubit in this direction, he effectively prepares a random minimum uncertainty state, namely either this one or that one, in Alice's lab. He cannot choose which one he will get, but he knows which one it is, and it will be one of these two. Now we already know that for the uncertainty game, both this state, as well as this one, is equally good. Bob can get the same maximum success probability. This means that Bob can essentially prepare a state which is optimal for the uncertainty game, and hence he can also cheat with the same probability. We have now seen a simple attack that Bob can perform for weak string erasure if he had no quantum memory at all. Note that, of course, in this attack he cannot guess the string x perfectly, but at least he can make the min into p as small as he possibly could.